Today we're looking at a programming language where overwriting a variable is, like, mathematically forbidden, alongside this developer's wild 20-year quest to programmatically click a single button in Windows. Welcome to DevTrends on the Go. Today's Qiita Picks, it's August 11th, 2026, and we've got a really great deep dive into the source material ready for you today.
Yeah, this quick format is it's basically perfect for your morning commute, keeping you up to speed on what developers are actually talking about right now.
And just for our listeners outside of Japan, we pull these trends from Qiita, which, if you don't know, is one of Japan's most popular knowledge-sharing platforms for software engineers. You can think of it as the Japanese developer community's version of dev.po or, Medium.
Right. It gives us a real-time pulse on what the engineering world is building. Oh, and before we get into the trending topics, just take a quick second to subscribe and leave us a like. It really helps us out.
Definitely. So let's jump straight into our first topic, which is all about the unseen constraints of AI. There's this massive search API showdown trending right now. A developer basically ran an exhaustive test comparing Amazon Bedrock's new native OpenAI web search against a totally custom setup using Tavily paired with Claude.
Yeah, and the scale of this test was pretty huge. I mean, they ran 220 distinct questions through both systems, and they heavily tested in both English and Japanese to see how localization impacted everything.
The final results were actually really surprising. On the overall scoring, they basically tied. Both landed right around 3.5 out of 5.
Oh, wait, so a tie.
Yeah, overall, but the underlying behaviors were super different. Like Bedrock achieved much higher scores on pure factual accuracy. But Tavily completely outperformed Bedrock when it came to citing verifiable sources and finding the most recent news.
How do you even grade 220 AI responses objectively, though? I mean, manual grading would take forever.
Oh, they used a methodology called LLM as a judge.
So just having an AI automatically grade another AI's test answers.
Exactly. They set the grading model's temperature to 0 so it wouldn't hallucinate, and just had it grade based on a strict rubric. But looking at the data, there was this wild anomaly. The Bedrock setup just decided to skip searching the web entirely, like 35.5% of the time.
Wait, really? It just didn't search. Doesn't that completely defeat the purpose of using a live search tool in the first place?
You would think so, right?
Yeah.
The author pointed out that exact frustration. Basically, if the model calculates that it already knows the answer from its training data, it just bypasses the search to save time.
Ah.
But when Bedrock did decide to search, its accuracy jumped from 4.03 up to 4.19.
That's a pretty critical detail if you're, relying on this for real-time financial data or something.
Right, and for our global audience, there's another factor here. Bedrock processed English prompts way more accurately than Japanese ones. Tavily performed equally well in both.
I'm guessing because Tavily has a deeper crawl of localized Japanese tech blogs?
Yeah, exactly. So choosing between them really comes down to compliance versus control. Native tools like Bedrock are great for corporate compliance because data never leaves your AWS environment. But custom stacks like Tavily give you precise control over language consistency. It's super useful for backend engineers deciding which API to bake into an enterprise app.
Speaking of controlling AI, that actually transitions perfectly into our next topic. Managing a model in your terminal as a daily coding assistant. It requires a totally different kind of control.
Yeah, we're seeing two major posts trending today focused on Claude Code. One, it's just a super practical cheat sheet for essential / commands like using /init to generate project summaries or /usage to track tokens.
Right, the basics.
But the second article dives into a much deeper problem. Writing a custom hook script to stop the AI from, basically losing its mind as the context window fills up.
Right, the custom hook script. It monitors memory, and when context usage hits 20%, it quietly warns Claude. And then at 25%, it forces Claude to pause and either finish the task or write a handoff note for a new session. But what exactly happens when that context gets too full?
So that's called context bloat. It's basically when the AI reads so much of your past conversation that it gets confused and just forgets your current instructions entirely.
Oh, wow. That sounds exactly like forcing an exhausted coworker to write a sticky note for the next shift before their brain totally shuts down.
That is a literally perfect analogy. As you fill up a massive context window, the signal-to-noise ratio just plummets. The model struggles to weigh new instructions against the pile of old code it just read.
So forcing that handoff note distills all that messy history into a clean summary.
Exactly. Automating that memory management stops the AI's performance from degrading over time. Plus, it stops you from burning your API budget, sending 50,000 useless tokens back and forth. It's incredibly useful for any developer using local AI to refactor large code bases.
And, managing local memory limits leads right into our third topic. How enterprises actually manage the massive documents an AI is allowed to read in the first place.
Right. There's this trending architectural walkthrough about using Oracle Cloud Infrastructure, specifically the OCI data catalog. They use it to organize huge libraries of Oracle database manual PDFs so an AI can search them securely.
And this relies on RAG.
Yeah, RAG.
Right.
Which just means letting the AI read reference material before it answers your question. Standard stuff today. You can route PDFs to vector embeddings, store them, and do a similarity search.
But if the AI is already reading the text directly from that vector database, why do we need this whole separate data catalog tool in the middle?
It's all about separation of duties. A vector database is great at finding text that matches your prompt, but it has no idea if a document is officially approved or current.
Oh, I see.
Yeah, so the data catalog acts as the system of record. It tracks the exact versioning and applies access control. So, like, a junior dev can't query executive HR documents.
So the AI handles the reading comprehension, but the data catalog is basically the librarian verifying the sources.
Exactly. Without it, the AI might give you a perfect summary of a server manual from 5 years ago. This setup guarantees the final answer has a trusted, official URL attached. It's vital for enterprise architects building secure corporate chatbots.
AI is getting all the hype right now, but I noticed a bunch of trending articles on Qiita today that are just pivoting straight back to absolute networking basics.
Oh, yeah. Sometimes you have to look at the underlying pipes. We have 2 standout articles today, one on firewalls and intrusion detection systems, and another breaking down the real mechanics of SSH connections.
The one about intrusion detection systems, or IDS, focused a lot on putting network cards into promiscuous mode.
Right, which just means setting a network sensor to listen to everyone's traffic, not just traffic addressed directly to it.
So it's like reading every single postcard passing through the post office to check for malicious stuff?
Exactly. But what caught my eye was the second article about SSH security. It dismantled a really common myth.
Hey, let me guess. The whole changing your port number thing. Because I always thought changing my SSH port to some random high number kept me safe. Is that not true?
It's totally not true. I mean, changing ports is just security through obscurity. It stops basic automated bots from filling up your logs, sure. But against a real attack, modern port scanners like Nmap don't care what port you use.
Because they just scan all 65,000 ports anyway.
Exactly. They'll find your hidden SSH daemon in seconds. The author argued that true security requires understanding architecture, like deploying a Bastion host.
Right, a dedicated server acting as the only entry point into a private network.
But the catch is, a Bastion host is both a single point of entry and a single point of failure. If an attacker compromises it, they have totally unrestricted lateral movement across your network.
So just securing the perimeter isn't really a viable strategy anymore.
Not at all. Yeah, and that's why zero trust architecture is so critical. Zero trust just means you assume the internal network is already compromised.
Right.
You don't trust a request just because it came from an internal IP.
You verify the identity on every single request.
Yep. These breakdowns are super useful for junior developers who are studying for security certs or just setting up their first cloud servers.
Well, while some people are mastering cloud security, others are apparently fighting decades-long battles with legacy Windows apps.
Oh man, this next article is wild. It's a fascinating story of a Japanese developer who spent 20 years, 2 decades, trying to properly automate desktop apps using Excel VBA.
Wait, are people seriously still using Excel VBA to automate UI in 2026?
Surprisingly, yes. If you work in modern web dev, it sounds crazy, but massive corporate legacy systems still rely on this. They use VBA to pull data from ancient desktop software into modern databases.
Okay, so what was the 20-year struggle about?
For years, the hack was using VBA to trigger a PowerShell script, which clicked the UI, wrote a text file, and a VBA read the file.
That sounds incredibly fragile.
And slow. Opening a simple calculator app took, like, 1.4 seconds. But the breakthrough came when a Qiita commenter showed the author a function called dispulfunc.
And that lets you bypass PowerShell.
Completely. It lets VBA talk directly to the Windows UI using memory offsets.
But wait, wouldn't finding the exact memory offset for a Windows API function be impossible? Doesn't Microsoft change those every time Windows updates?
You would think so, but no. It's because of COM, the component object model from the early 90s. The strict rules of COM dictate that once a memory offset number is published, it can never, ever change.
Oh, wow. So if they changed it, every legacy app would just crash.
Instantly. So the author realized the exact memory offset he needed to click a button 10 years ago was mathematically guaranteed to be the same number today.
That is amazing.
By using that frozen memory address, the execution time dropped from 1.4 seconds to 0.35 seconds.
That's a huge optimization.
It really is.
Yeah.
It shows that sometimes the barrier isn't your skill, it's just finding the right obscure documentation. This is a goldmine for RPA, or robotic process automation engineers, maintaining enterprise workflows.
Okay, so from a 20-year-old VBA struggle, let's look at something even older. A language from 1982 that is suddenly highly relevant for quantum computing.
Yeah, let's shift gears entirely. We're talking about Janus, a programming language designed to run backward.
Running backward, how does code even execute in reverse?
It's built on a concept called reversible computing. It basically means writing code, where you can undo every single step perfectly, like hitting rewind on a video.
Okay, but why can't I just run standard Python or JavaScript in reverse?
Because standard code actually destroys information. Think about a normal assignment. If you say x equals 5 and later say x equals 10, that 5 is completely erased from memory. You can't reverse it because the past state is gone.
I see.
So Janus, standard assignments are completely forbidden. You can only add, subtract, or swap values.
But what about an if statement? So a standard if statement is kind of like a Y intersection on a road. Reversing it is impossible because you don't know which branch you came from, unless you leave breadcrumbs.
Exactly. That is exactly why Janus requires assertions at the start and end of every single loop and branch. You leave explicit logical breadcrumbs. So when the program runs backward, it reads the ending assertion to know which branch to travel up.
Okay, but why is this 1982 language suddenly trending today?
It's all about physics. Specifically, erasing a single bit of information physically releases a microscopic amount of heat.
And quantum computers have to operate at near absolute zero, right?
Yep. If a quantum logic gate destroys information, it generates heat and the quantum state collapses. So all quantum operations have to be perfectly reversible. An engineer on Qiita actually built a TypeScript version of Janus called UNSAL specifically to generate reverse circuits for quantum algorithms.
Wow.
It's totally fascinating for quantum computing researchers and programming language nerds.
It's really wild to think about the sheer breadth of what we've covered today.
Yeah, I mean, it's crazy to think that our industry is simultaneously struggling to manage AI memory limits, celebrating 20-year-old Windows memory hacks, and writing code that runs in reverse for quantum chips. The definition of programming is just expanding in every direction at once.
It really is. Well, if you found today's deep dive useful, please make sure to subscribe and drop a like. We'll have a brand new selection of developer trends ready for you tomorrow.
Have a great day and happy coding.